Hello, everybody. Let's start a little bit of a review of basic algebra. So today we're going to review the laws of exponents. Your objective is you will know and be able to use the properties of exponents. That's something you've learned in Algebra 1 class. So let's take a look first at the product law. So what is the product law saying? It's saying that you have to add the exponents together when multiplying the powers with the same base. Like, for example, 3 to the third power times 3 to the 12th power. See, the bases are the same, 3. So all you have to do is keep the same base, 3, and add the exponents. 3 plus 12 is 15, so the answer is 3 to the power of 15. This operation can only be done if the base is the same. Very important. Let's simplify this on your own. X to the third times x to the fifth. You see the base is the same, x. So all we have to do is add the exponents. So 3 plus 5 is 8. So the answer is x to the power of 8. Here in the next example, you have two of the same bases. X cubed, x squared, and y to the fourth, y to the fifth. And because you have to multiply them, we are going to do it one by one in order of the variables. So x to the third power multiplied by x to the second power will be x to the power of 5. Why 5? Because 3 plus 2 is 5. And y to the fourth power times y to the fifth power will be y to the power of 9. Why 9? Because 4 plus 5 is 9. Let's take a look at the second law, power of a power. So what does the power of a power say? Keep the base and multiply the exponent. As you could see here, you have only one base, 4. And then you have exponent and the exponent outside of the parentheses. So all you have to do is keep the same base, 4, and you multiply the exponents. 3 times 5 is 15. So the answer is 4 to the power of 15. Remember to multiply the exponents, not add them. So let's simplify these on your own. So x to the power of third, everything to the fifth power. So keep the same base, x. 3 times 5 is 15. Voila! Here's the answer, x to the power of 15. Here we have more than one base, so we're going to do it one by one. So x cubed to the power of 4 and y to the fourth to the power of 4. So again, we keep x and we raise it to the power of 12 because 3 times 4 is 12. And y would be raised to the power of 16 because 4 times 4 is 16. Let's take a look at the third law, power of a product. Distribute the power to each number of the variable in the parentheses. So as you could see, right here is 4 to the power of 1. All right, because it's on its own. The same thing with x to the power of 1. When you distribute 3 times 1 is 3. So then 4 to the power of third, x to the power of third. And 4 to the third power, we can simplify a little more, and that becomes 64 because 4 times 4 times 4 is 64. And so my final answer is 64x cubed. So you would multiply the exponents, not add them. Let's simplify this on your own. So again, -2. Remember, negative stays with a 2, and you raise it to the second power. And then a is raised to the second power. But -2 squared is positive 4, so therefore the final answer is 4a squared. The same way here, 3 is to the power of 1. When you distribute the exponent, 3 to the second power, x to the 6th power, y to the 8th power. But 3 to the second power is 9, so I can just change it. Let's take a look at the zero exponent law. This is the best law I came across from. So any power raised to an exponent of 0 equals 1. So I don't even have to think of what's inside the parentheses because the outside power is 0. The answer is right away 1. And so here the outside power is 0. So the answer is 1. So is the answer to this problem. Let's take a look at the negative exponent. To make the exponent positive, you have to flip the base. Look, the base here is 2. If you flip the base, it will be 1/2. And now your negative sign of the exponent changes to the positive. So then 1 to the fourth power is 1, so therefore we get 1 over 2 to the fourth power, which is 1 over 16. That does not change the sign of the base. The common mistake when you put a negative in front of the entire fraction, that's not true. You have to just flip the base. Now let's take a look at the next problem. X to the negative third power, flip the base. That will be 1 over x to the third power. Flip the base here, but before we do, we have to distribute the exponent. That becomes 2 to the negative second power, x to the negative 6, y to the negative 8. And when you flip each of those bases, we get 1 over 2 to the second power, 1 over x to the sixth power, 1 over y to the eighth power. And then simplifying further, here is our answer. Let's take a look at the quotient property. So subtract the top exponent minus the bottom exponent as long as your base is the same. 12 minus 4 is 8, and so 3 to the power 8 is my answer. The same way here, but look, 4 is the only one number that you see there. It doesn't have any other 4 to any other power. So then we're going to leave it alone, and all we have to do is deal with a to the fifth and a to the second. We are going to subtract the exponents because there's a division sign. So therefore the answer is 4a to the third power. Now let's take a look at the next one. We do the same. When you do the same, you subtract 3 minus 7, that becomes negative 4. And now look, negative exponent is only over y. So therefore, we flip only y. That becomes 1 over y, and 3 stays in its place. So it's 3 times 1 over y to the fourth, or 3 over y to the fourth. Let's take a look at the quotient property. So again, the quotient property says distribute the power to the top and the power to the bottom of the quotient. So therefore, we get x to the third power and 2 to the third power. X to the third power stays, but 2 to the third power is 8. We change it and we're good. The same way here, when we have more than one term, we distribute to each of those. And so that becomes 2 to the third, x to the third, 3 to the third in denominator. And then when you simplify, that would be 8x cubed over 27. Now let's take a look at this problem. Again, negative exponent. So I distribute the exponent. That would be negative 2 to the negative fourth power, a to the negative fourth power, b to the negative fourth power in denominator. So now I could do the reciprocals. So if I do so, I get b to the fourth power, because reciprocal of 1 over b to the negative fourth will be b to the fourth. And the same way with negative 2 to the negative fourth becomes 1 over negative 2 to the positive fourth. And a to the negative fourth becomes 1 over a to the positive fourth. And the only thing I could do is simplify negative 2 to the fourth power. That becomes 16. And that's it. So let's review. Students will understand and be able to use zero and negative exponents. How? Any number but 0 raised to the 0 power is 1. 0 raised to 0 power is 0. Negative exponents means reciprocals. And another one, student will know and be able to use properties of exponents. So when you multiply the same base, you add the exponents. When you divide the same base, you subtract the exponents. A power raised to a power, you multiply the exponent. And you can distribute exponents across multiplication and division only.